This lesson is for section 5.1, exponential functions. We're going to go through a couple different things. We're going to be graphing exponential functions. We're going to be estimating powers of 2 in terms of powers of 10. We're going to be simplifying and solving exponential equations. So we've got a lot of stuff kind of all packed into this first lesson. But first I want to come up with a scenario to help you kind of understand exponential functions. Your parents are demanding that you get a job to help pay for college. You've got two different options that your parents have lined up for you. In option one, a guy your dad knows is a hotshot lawyer who's willing to pay you a lot of money every day, $700 per day, if you'll be on call 24/7 to be his personal assistant. So it seems like a pretty good paying job. Now in option two, your mom knows a guy who runs a nonprofit animal shelter, and he pays you this very unique salary. Seems a little odd, but he says he'll pay you 2 cents to start on the first day, and then he'll double your pay every day after that. So only 2 cents on the first day? That doesn't sound so good. This guy must be a little bit nuts. Now, option one can be shown as a linear function. If he's going to pay you $700 per day, we can use linear function 700x to represent that. So on day one, you get $700. At the end of the week, after 7 days of working for him, you've made a total of $4,900. Now in option 2, at 2 cents, and then 4 cents, and then 8 cents, this is going to be found by showing an exponential function, y equals 2 to the x. Now after day 1, only 2 cents you made. Day 2, 4 cents, so a total of 6 cents there. And then at the end of 7 days, on the 7th day you made $1.28, and if we total up everything else, end of week 1, you're at $2.54. So it looks like option 1 is pretty good so far. Now, if we compare both options over 30 days, we see that we make, at the end of 30 days working for this lawyer, $21,000. That's a ton of money. Okay, it's a lot of money. In option 2, at the end of 15 days, that looks pretty good at $32,768, but that's in pennies. So really, that's only $327.68. Plus, the day before you made around $16, or I'm sorry, $160. So you got to add up all of those again to account for how much you actually have made at the end of the 15 days. Now let's take a look at the 30th day and how much you've made in option 2. At the end of the 30th day, on the very 30th day, you've made 1,073,741,824 pennies, which, if we move our decimal 2 spots over, is actually $10,737,000. So you made that on the 30th day. On the 29th day, you would have made $5 million, and on the 28th day, you would have made half of that, so $2.5 million, and so on. So you've made a ton of money. So just like that money situation just started to explode once you got to the 30th day. When you see a viral video, like a YouTube hit, like Gangnam Style, really the term going viral doesn't really quite hit it. It's actually going exponential. Here's a curve that shows the exponential growth of a video, Gangnam Style. I think now with your new knowledge, you should probably go around and police this situation. Anytime someone says going viral, please speak up and let them know that it should be going exponential. But
ain't nobody got time for that.
Okay, now coming back to our notes, what we're going to do is use one of the values that we saw when we raised 2 to the 10th power. That was equal to 1,024. That was that 1,024 pennies that you would earn on the 10th day. Well, 1,024 is awfully close to 1,000, so 10 to the third is approximately the same as 2 to the 10th power. Okay, we're going to use that when we try to estimate larger powers of 2. So 2 to the 40th, I can rewrite this as 2 to the 10th raised to the 4th power. That's equivalent. Now 2 to the 10th, I'm going to use substitution here and say that, well, that's approximately 10 to the 3rd power. So if I want to rewrite this, I can say that this is 10 to the 3rd to the 4th power, which is equal to 10 to the 12th. So 2 to the 40th is approximately 10 to the 12th power, which is 1 followed by 12 zeros. Oops. And I believe that's $1 trillion. Okay? Or sorry, just 1 trillion. Now when we do 2 to the 21st power, we want to use the same idea. We're going to break this down and say, well, this is equivalent to 2 to the 10th power squared times another 2. Okay, because altogether that would give me 2 to the 21st power. Now 2 to the 10th, let's substitute in 10 to the 3rd here. This is going to be approximately 10 to the 3rd squared times 2, which gives me 10 to the 6th power times 2. So this is going to be 2 times 1 followed by 6 zeros. So we have 1 million multiplied by 2 to give me approximately 2 million. Alright, our next skill is that we're going to be working with irrational exponents. We need to be able to simplify those kind of expressions. So when you take a look at this first one here, all that you're doing when you have, this is the same as 2 to the 3rd times 2 to the 2nd, all you would be doing here is adding your exponents. So I'm just going to take 2 and raise that to the sum of my 2 powers. And simplifying here, those root 3's are going to cancel, and I'm left with 2 squared, and that equals 4. So this problem, although it looks like a beast, is actually pretty easy. Now number 4, when you have a power raised to a power, these powers are going to multiply. So we have 3 to the root 2 times root 2, and this is the same as 3 squared, and that simplifies to 9. Now the same thing goes for this problem here, and I can rewrite this as 3 raised to the 2 root 2 power, or 3 raised to the 2nd power raised to the root 2 power. I can switch these powers here, and I can simplify this and make that 9 root 2. So it's just a matter of making it a more convenient, rewriting it in a more convenient way to simplify that a little bit more. You will also be solving exponential equations. Remember, when you want to solve an exponential equation, you have to have the same base on both sides. So in this first example here, because our bases are the same, that means that our powers must also equal each other. So to solve this, it's pretty simple. We would get x equals -3. Okay. Now in number 7, we need to rewrite this so that we have the same base on both sides. I could rewrite this 9 as 3 to the 2nd power raised to the x minus 1, equaling 3 to the 3rd power raised to the 2nd power. So now I'm just going to set my exponents equal to each other. The only thing you have to really be careful about here is making sure you distribute that 2, because you're multiplying 2 times x minus 1. So we end up with 2x minus 2 equaling 6. On the other side, we multiply these 2 powers as well, and we end up with x equaling 4. Now in number 8, this is technically not an exponential equation, but you will still be solving problems where you have an exponent and you need to be able to raise it to the reciprocal power. So if I want to isolate x here, what I need to do is raise this to the -4/3 power. On both sides, I'm going to raise it to the -4/3 power, and this is now going to become x to the 1st power, which is what I want. I just want x alone. So I have x equals now 8 to the -4/3 power. I want to rewrite 8 as a base of 2. So I have 2 to the 3rd raised to the -4/3. Now these, when I multiply them, those that rational part is actually going to cancel out here. Those 3's are going to cancel, and I'm going to be left with 2 to the -4th power. So x equals 1/16. 2 to the -4th is 1/16. In problem number 9, remember that 3 to the -1st power, which is kind of what we just talked about over here with 2 to the -4th, is equal to 1/3, right? 1 over 3 to the 1st power. And vice versa, if you have 1 over 3 to the 2nd power, that's equal to 3 to the -2nd power, okay? So those are equivalent. Now when I see this over here, and I notice that I can write, this is a base of 3 on both sides, I'm going to rewrite this as 3 to the -3x minus 2. So I'm raising that now to the negative power and bringing that to the numerator. So on the other side, I have that equal to 3 to the 3rd. And now I can just set these powers equal to one another. So negative times 3x minus 2 equals 3. And then I'm going to just solve that very simple linear equation. In problem 10, I'm going to let you guys finish this one off and then just check with the key. But in problem 10, it's kind of the same idea here. So you guys should be able to finish off 10 and 11 and just get that extra practice and check. Okay, so we're going to next take a look at properties of your exponential functions, and when you graph them, we're going to be graphing using transformations. So I first want to be able to fill this out by looking at some specific exponential functions. So here I have the graph of y equals 3 to the x. So take a look at some of your important points here. If I plugged in -1 into this function, I would get 1/3 for the y. If I plug in 0, I get 1, and if I plug in 1, I get 3. So here are my 3 very important points here. Now, if that function becomes y equals 4 to the x, look at how similar these are. We still have a y-intercept here at 0, 1, and our key points here are very similar, and they're not the same, but they're very similar. And then if we look at y equals 5 to the x, we see the same exact y-intercept. If we look at y equals 2 to the x, same thing, same exact y-intercept. We still have very similar key points. So when we take a look at properties of an exponential function in the form y equals b to the x, and b is greater than 1. If you noticed all of those graphs, we have a base that was greater than 1. Our domain is always negative infinity to positive infinity. Our range is from 0 to infinity because we have an asymptote. If we take a look back over here, we have an asymptote here at y equals 0. Okay, this function, anything I plug into this function here can never actually become negative or equal 0. So we have an asymptote at y equals 0. We have no x-intercept. We have one y-intercept at 0, 1. We have a vertical asymptote, or I'm sorry, we don't have a vertical asymptote, and we have a horizontal asymptote at y equals 0. For our end behavior, as this function here approaches negative infinity, it approaches 0. And as x approaches positive infinity, y also approaches positive infinity. Okay, so I want to actually take a look at y equals 3 to the x a little bit closer. So here we've got our three key points here. And now I'm going to transform this equation slightly. If I were to take y equals 3 to the negative x, notice how this has been reflected over this y-axis. Okay, so take a look at how your points have now become inverted by, you have a negative 1, 3, 0, 1 is still the same, but this now becomes positive 1, 1/3. And if we were to take a look at this, I do want to note though that also 3 to the negative x is the same as 1 over 3 to the x. Okay. And also, if we look at y equals 3 to the x minus 1, now everything's been shifted down. So we look at our original blue graph here, and everything has been shifted down 1 point. So now our intercept is at 0, 0. That point that was at 1, 3 is now at 1, 2. The point that was at negative 1, 1/3, that should say, sorry, that's actually incorrect here. It should be negative 2/3. And if we look at the graph of 3 to the x minus 1, this time all of our points, our y-intercept here at 0, 1, is now shifted over to 1, 1. Okay, everything has been shifted to the right 1 value. So it's affecting our x-coordinate there. So just to recap our transformations, when you see a function here in this form, when you have a negative out in front, it's reflected over the x-axis. Okay, when you see negative on the inside, you want to factor that out, and then you're going to look at the fact that it's flipped over the y-axis, which actually, if I go back, looks more like this one here. So this is flipped over the y-axis because we see that negative x here. So that's why we're seeing this. And come back to this. This number here is a horizontal shift to the left or to the right, and it's the sign. You look at the sign, but you take the opposite of it. Okay. And finally, after the function, you look at this number here, and it's going to move it up or down. It's a vertical shift up or down, and you keep the sign the same. Okay, so that's just a review of your basic transformations. So we want to keep those transformations in mind when we start trying to graph these different sketches here. So I want to sketch the graph of 2 to the x. Well, I know that this should look very similar to our 3 to the x, where we have a y-intercept at 0, 1. We should have the point 1, 2, and we should also have the point negative 1, 1/2. And that's just found by, if you plug in negative 1 here, we get 1/2. Okay, so that's how I find those three key points here. We do have an asymptote also at y equals 0. We have a horizontal asymptote as well. And then when I graph 2 to the negative x, I know that this is a reflection, a flip over the y-axis. So now my sketch should look like that. Okay, and I take our point 0, 1, I keep it the same. Now, if you were to find this actual coordinate here, trying to find it on here, well, this number, it's a flip over the y-axis, right? So it's taking your coordinate, x, y, and you're going to multiply the x value by negative 1. So xy becomes negative xy when you flip it over the y-axis. So this coordinate, 1, 2, after you multiply this number by negative 1, becomes negative 1, 2. Okay? And the point negative 1, 1/2, when you multiply that number by -1, it now becomes 1, 1/2. So that next point here, 1, 1/2. We still have a horizontal asymptote at y equals 0. So when you're graphing, when you're giving these sketches, what we're looking for on a test or a quiz is to make sure that you list your important points. You want to see a y-intercept, you want to see some critical points like that we have here, the 3 here, and you also want to graph your horizontal asymptote. If the graph does end up crossing the x-axis, because it can if it's shifted down far enough, then you want to include that point as well. Now in y equals 1/2 to the x, we could rewrite this as 2 to the negative x power, right? This works just based off of our exponent rules. So this graph is actually the exact same as graph number 13. Okay, so I'm not going to take the time to graph this. This is kind of the whole important point, though, is that you need to be able to recognize that and rewrite that as an equivalent exponential equation. In number 15, now we have two different transformations. We have a flip here, but this time the flip is over the y-axis, I'm sorry, the x-axis. So it's flipped over the x-axis, and this is going to be a shift to the right by 3 units. Okay, so we have a flip over the x and a shift to the right by 3 units. When you do your transformations, you want to do in order of operations. We would multiply before we added, so when we take our key points here, and our key points should be 1, 2, 0, 1, and -1, 1/2. Those are the same points from y equals 2 to the x. We want to translate these points by multiplying. If we're flipping over the x-axis, this time x, y becomes x, -y. So we multiply the, the y by -1. So that point now becomes 1, -2, 0, -1, and -1, -1/2. Okay, so that's applying just our flip first. So this is just the flip. The second part that we need to also apply is this transformation right 3. Okay, so right 3 is a horizontal shift, which means it's affecting the x coordinate. So now we actually want to add 3 to all of our x values. So we're going to look at this point here and add 3 to this. For just the x, we end up with 4, -2, 3, -1, because I'm adding 3 to this coordinate. Add 3 to this coordinate, and I'm at 2, -1/2. So these are the points that I'm actually going to plot here. Okay, now that I've plotted that, those points here, the only point that I'm missing that I actually want to see on a test or a quiz is the y-intercept here. So to find that y-intercept, remember you're plugging in x is 0 to find that y output. So you're going to just take your function here and plug in 0 into the original function, so we end up with y equals -2 to the -3rd power. 2 to the -3rd power is 1/8, and then we take that sign out in front, the negative here, so that coordinate is at 0, -1/8. Okay, and then all the other points we've already found here, those are the points here that I plotted, and this would be a good sketch. You also want to include the fact that you have a y, or an asymptote at y equals 0 as well here. Okay. All right, I'm going to erase and then work on number 2 with you, and then I'll leave you guys to do number 3, or 17, I should say, on your own. Okay, this time in problem 16 here, I see that I have a negative sign here, and I want to factor that out just so I can see where that shift is going to occur from this number here. So I see that I have a flip over the y-axis, which is why that negative is here, and I'm also going to shift it right 3 units here. So when I take my points, and our important points 1, 2, 0, 1, -1, 1/2, these are going to get affected first by flipping it over the y-axis. Since I'm flipping it over the y-axis, remember you're taking the point x, y, and it's now going to become -x, y. Okay, so we multiply all of these values here by -1, and I'm at -1, 2, 0, 1, 1, 1/2. So instead of my sketch looking like this, since it's flipped, it's going to look something like that. And then of course we also have to translate this 3 units to the right, so everything's going to shift to the right 3 units. Now, because it's still a shift in the x, that means that I'm still going to add to the x value here. So I would add 3 to each one of these coordinates, and I'm at 2, 2, 3, 1, and 4, 1/2. So these are the points that I would plot. So I'm going to do that really quick. I'm going to erase so that I clean this up a little bit and graph that. Okay, now in number 16, I do have 2 things that I'm missing here. I want to make sure I show where the the horizontal asymptote is at y equals 0. And I also want to show this y-intercept. Now the y-intercept again is found by plugging in 0 for the x, so I have 2 to the third power, which gives me 8, so that point is at 0, 8. So that's what we're looking for. We're looking for some additional points in your graph. You can use our 3 basic points, and as well as the y-intercept if that's not already included with those 3 basic points, and the horizontal asymptote. So try number 17 on your own and check with the key. That is the end of the lesson.